welcome to another online video. 10.3 is our lesson for today. We're going to be dealing with surface area. We're going to also be using rectangular prisms and finding the surface area of those kinds of three-dimensional figures. Please fill out your table of contents. I'm on page 98. You can just do SA for surface area to save some space, but it is going to be a rectangular prism, so make sure you fill that out and fold your note sheet. So in class today, you learned how to take a three-dimensional rectangular prism and break it down and create what's called a net. You can see from this picture and this picture, it's actually the net is drawn on grid paper. That's what we used in class today. But you can also see that the grid or the net behind the two-dimensional drawing doesn't have to be. You can just use a blank piece of paper. So hopefully from class today you realize that nets can look different if you have the same shape. You can choose to put the sides attached to different parts of the middle, but for the most part you see this T looking shape, except for this one. All of the rest of them look like a form of a T. Sometimes it's a wider T, sometimes it looks more like a cross, and sometimes it looks like this one where the ends are at the top. So just to review what we did in class, the surface area is what we're talking about. It's literally the area of all the surfaces, and the net is an orthogonal drawing. We said that earlier. And that means it's a two-dimensional drawing of a three-dimensional figure. And if we were to have this shape broken down and drawn out, we would have something like this. Obviously, this is only one way to show the net. You could take these ends and put them up attached to this one, or this one, or this one. Hopefully you have that knowledge from what we did in class. The other point I wanted you to put on your notes is that it's important to chart or make a table of all of the parallel faces and their areas, and also just realizing that drawing, whether you have grid paper or whether you just have blank paper and you're just putting the dimensions in, drawing the nets help you see what dimensions are what. Right underneath that in your notes is an example of what your chart should look like. You do not have to write front and back all out. You can just use the abbreviations F, and because there is a bottom and a back, I choose usually to show the back as BK. Top bottom can be just TB, and side can be S/S. And then you should have a column for your area dimensions, the length and width that you multiplied, and then you can double the answer. And this is an example on your front cover of one three-dimensional rectangular prism, and then it broken down into its 6 pieces. So go ahead and label. This could be the top. If that's the top, this is going to be the bottom. If I go from the top down to the front, I could go over to the back, but the back is going to be attached to the bottom in this case, and then the sides are literally on either side of this orthogonal drawing. If at the end of the video you want to come back to the front and actually fill in this table with this diagram to just do extra practice, that would be great. In your notes, let's fill this in so you have it. To find the surface area, you did a little bit of this today in class, but here it is for your notes. You have to find the area of all of the faces, of all of the surfaces. Then you simply add them up. There is a formula, and this is the new part we didn't really talk about in class today. There is a formula that you can use for finding surface area of rectangular prisms. It's a little complicated, but if you hang with me, I'll explain it. You can take 2 and multiply it, because there are 2 front and backs, and we'll call that the length and the width to get the area. You could then add 2, and then you can take the length and the height, that would be the bottom and top, and then you can take 2 and multiply it times the width and the height, and that would be like the sides. So this is just a numeric and letter representation for your chart. Using the 3 numbers that you have, the dimensions of length, width, and height of your 3-dimensional rectangular prism, you could plug those numbers into this formula and get the same answer as when you chart it out. So on the inside, you have a couple of examples. I'm going to show you how to do the chart and the formula. So here is the 3-dimensional rectangular prism, and we already have the net drawn for us. That's great, perfect. We can use that to help us chart it out. So your chart should have the faces, the area, and then the fact that you have to double the area. We're going to do the top and bottom first. The top dimensions are 5 and 7. So those are the numbers that I'm multiplying together, and that equals 35 when I double that. So I get 70 for both the top and bottom. Let's do the front and back next. The front and back is this 7 and 4. Plug that in. That's 28. When I multiply that by 2, I get 56. The last one I need to do is the side. That's S and S, and it's 5 times 4, which is 20. And when I double that to get both of them, I get 40. So to find the surface area after I've used the chart, I'm simply going to add up those 3 numbers. I've already doubled the top and bottom, back, front, and side, so I am adding up all of the spaces sides. When I add that up, it comes out to 166. Our unit is feet, and now because we're finding area, it's back to that square. Now I'm going to use these 3 numbers as the length, the width, and the height, and show you how you can use that formula. So the surface area, we're going to take twice the length and the width. That's like the top and bottom. Then we're going to take twice the length and the height. That's like the front and back. And then we're going to take twice the width and the height. Now let's plug in our numbers. We have the length of 7 and the width of 5. Then we're going to plug in the 7 again for the length, but then we're going to use the 4. And then we're going to have the width, which is 5, and the height, which is 4. So you can see right away, this was the 7 and the 5, this is the 7 and the 4, and this is the 5 and the 4. It's really the same thing. One's a formula, one's a chart. That's it. And then the math ends up being the same exact thing as what we experienced with our chart. Plus 2 times 20, I get the 40, and then the 56, and then the 70. Obviously, when I add all of those up, it will give me the same answer as 166 feet squared. Chart, formula, either one is perfectly good way to use for finding surface area. This second example does not have a grid behind it. That's okay. Notice the numbers are all around and they refer with little lines to what section they're referring to. So this 10 has a line here and here, noticing that this part of the net and this part of the net is both 10. Go ahead and actually scrounge around for 3 different colors. If you don't have colors, you can decorate the inside by shading the front and back. You can do polka dots, and you can do stripes. So if you don't have colored pencils or crayons to actually shade with the 3 colors, go ahead and do what I did with my 1 marker, just to make sure you see that the blue squares are the same, the yellow rectangles are the same, and the green rectangles are the same. We can also label these if it's easier for us to keep track of. This could be the top, the front, the back, and the bottom. And this could be the side and the side, just to give us a sense of, oh, which one am I talking about? Again, I'm going to do the chart and the formula so that you can see both. So I'm going to start with my side. Doesn't matter which pair of parallel faces you pick. I'm going to pick the side and the side first. So that's 15 and 10. When I multiply that, it's 150. So when I double it, it's 300. That's the first number I'm going to use. Now let's do our top and our, I mislabeled this, sorry. Here's the back, front, back, top, bottom. So here's the top and bottom, which is 10 and 10, which is 100. When we double that, it ends up being 200. The last one we're going to do is front and back. That would be this middle guy. Remember, rectangles have opposite sides that are the same. So if this 15 of the green rectangle, this is the same 15 for the yellow. If this blue part of the top is 10, that means this also is 10. So we have another 15 by 10 area, which is another 150. When we double it, we get another 300. To find the surface area, we're going to simply add 300, 200, and 300 up together. When we do, we get a lovely 800. Because our unit is inches and we're dealing with area, the final answer is 800 inches squared. Now let's do that formula. Before we can though, we need to decide that the 15 is going to be the length, the 10 is going to be the width, and the h is going to be the 10. Just so that we can keep our numbers straight, there's 3 different dimensions, obviously, for the rectangular prism, length, width, height. We're going to use the 10, 15, and the 10, and here's our formula. We're going to take twice the length and the width, plus twice the length and the height, plus twice the width and the height. So that's going to be equal to the 15 times the 10. Then we're going to double the length, which is 15, and the height, which is 10 again. And then the last piece ends up being the width, which is 10, and the height, which is 10. So you see that there are 3 separate parentheses standing for the 3 separate kinds of faces that you were finding the area of. The math ends up being exactly the same. And when you add 200, 300, and 300, sorry, I forgot my surface areas over here. To make it an equal equation, you get 800 inches squared. So the last one over on the right does not have a net. I'd like us to practice drawing that together, and then we'll use the net and the shape to find the surface area the 2 different ways with the chart and the formula. So when I start with my drawing my nets, I want to pick a face to start with. I'm going to start with the top. And the top has 2 dimensions, the length and the width. And this is going to be the height. So we'll use those when we do the formula. But in order for us to draw the net without any graph paper, we're just going to draw rectangles. It does not have to be to scale because we're going to put the numbers next to them. So I have a rectangle that represents the top, and I want it to be labeled 7 and then 4.8. It's 7 by 4.8. If I were to then take from the top and go down, I could either go down to the front or I could go down to the back. I'm going to go from the top to the front next because that's going to have that same edge that's connected to it that's similar. I'm just going to drop this down. It's going to be a little bit bigger because it's 7 by 6 now. After I draw the front, I have to go down again to the bottom. Here's the top, here's the front. Now I'm going to draw the same rectangle that was the top is going to be the bottom. It's going to still be 4.8 and still 7. I'm just connecting them. And then I'm going to need another one that looks like that size approximately, doesn't have to be perfect, and we're going to label it the back. Now all I gotta do is put my two sides somewhere along this column of rectangles. My side is going to be this part right here. It's the height of 6 and the width of 4.8. I'm going to choose to put, I'm going to erase this 6, two rectangles. This is still 6 on either end to make that T shape. And now I just have to draw a line to that 4.8, and this guy over here is also 4.8. That is our net. Now we can use this picture as well as that to help us find our surface area. So here's our chart. We're going to start with our top and our bottom. The dimensions are going to include a decimal. We can use our calculator. So we're going to multiply 7 times 4.8. When we do, it ends up being 33.6. And then we're going to double that, which is 67 2/10. That's our first number that we need. Then we're going to go to the front and back. Those dimensions will be 7 times 6, which is 42, no decimals, but we still have to double it, which is 84. The sides are the last thing we have to chart out, and that's going to be the 4.8, this right here, and then the 6. When we pop this into our calculator, it ends up being 28.8, and when we double it, it ends up being 57.6. Now we have to add these numbers up. Surface area is going to be 67 2/10 plus 84 plus 57.6. Surface area altogether is 208.8. Because this is centimeters and because it's surface area, we need a label of centimeters squared. I'm going to get rid of this just because of space so that I can show you the formula. So surface area, we're going to double the length and the width. We're going to double the length and the height. And then we're going to double the width and the height. So the surface area, when we pluck and plop those numbers in, we're going to have the length and the width. So that's the 7 times the 4.8. Then we're going to double the length and height, which is the 7 and the 6. And then we're going to double the width, which is the 4.8 and the 6. The numbers are the same, so fill those in. So here it is where I've multiplied just like before and then doubled. We end up adding up the same 3 numbers and getting the same answer. Look forward to working with you more with surface area tomorrow with charting and formulas. Have a great rest of your day. See you tomorrow. Bye.